Okay, so the last part is asking you for the regression, right? An emergency service wishes to see whether there's a relationship between the outside temperature and the number of emergency calls received in a 7-hour period, right? The data are shown. So find the sample correlation coefficient and describe what it represents accordingly. Find the equation of the best line or the regression line for the sample data. Find the coefficient of determination and briefly describe what it means or describe its meaning. Is there enough evidence of a linear relationship between the temperature and the number of emergency calls at 0.05 levels of significance? So before we have to do this by the formulas, R equals SXY divided by square root of SXX, SXY. You don't need to do that this time. You're going to use technology and we're going to do this faster. So the first question is asking you for the correlation coefficient. And the second question, or part B, is asking you for the line of best fit or the regression line. And then part C is asking you for the coefficient of determination, right? So let's do those three really fast. So we go to, give me 1 second. Let's go to here really fast. Let's put this data in here. Okay, so I already have that data in my in the video. I already put it. The data from the question 68, 74, the temperature and the number of calls. So you go to stats. Once you input the data and you go to calculation, you go to regression, which is number A. Click enter, 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 enter. And that's your equation right there, right? So the first question is asking you for the sample correlation coefficient. That's R. So that's 0.8113 or 0.81. So the question is, briefly describe what it represents. It represents the correlation between the temperature variable X and the number of calls Y, right? So the relationship is very strong, right? It's highly strong, right? So part B, find the equation of the line or the regression line. So you have the what A and B are. So you just write the equation will be y hat equals A, which is negative 7.54 plus bx. B is 0.1897. And yeah, so that's X. And part C, they're asking you find the coefficient of determination. That's just R squared. R squared here is 0.66. So now that I have that, I can go back to the slide. Okay, so let's go back to the slide. Okay, okay. So far we have the sample correlation coefficient. So it's 0.81. What it represents the correlation between these two variables, X and Y. So that's that part. So I just explained to you what that represents. Find the equation of the regression line. So this is the equation of the regression line with a calculator. So we save a lot of time by using technology. Find the coefficient of determination. So we found the coefficient of determination. This is this thing here. And they say here, and briefly describe what it represents. Well, the coefficient of determination, what it represents is what percentage of the total variation or what percentage of the variation in Y is explained by the variation in X. So what this means, so for example, if you have let's say that this is your data points, you have 2, 4, 6, 7. So let's assume that it's 1, 2, 3, 4, 5, 6, 7. Let's say that the regression line is somewhat like that. So the correlation coefficient, it tells you how strong the linear relationship might be, right? It might be the strong linear relationship, might be negative linear relationship. That's what the coefficient, the correlation coefficient tells you, right? The R squared, it tells you basically what this line explain with respect to the variability, right? So this line, this line negative 7.54 plus 0.97x represents 66% of the variation of the data points. Okay, so it represents 66% of the variation of these data points. The other 34%, this is explain 66% of the variation, right? And the other 34% is unexplained. So there's some percentage that is unexplained by this line. So there's something that the regression line cannot tell us about the variation, right? If I want to go deep into this, I can go very deep into this, but that's not the point. The point is briefly describe what this means. So if they're asking you what is the correlation, the coefficient of determination does, it tells you basically what percentage of the variation of Y is explained by the variation in X, period, right? So 66% is explained by this line, right? 66% of the variation is explained by this line, right? And 34% is unexplained. Now, the last part is asking you, is there evidence of linear relationship between the temperature and the number of emergency calls? So you have to do a hypothesis testing here, right? So H naught will be rho equals to, there's no relationship. So in other words, no correlation. And the alternative hypothesis would be there's a correlation, right? Correlation exists, or so we need to find out if this is the case, right? So we need to do a test for that, and you're gonna tomorrow when you come to the test, you're gonna need some formulas, okay? So this is gonna be R1 minus R squared n minus 2. So this is for the t-test, okay? And you need to bring your formulas or a cheat sheet for tomorrow, okay? So please don't tell me tomorrow that you forgot the cheat sheet. So R, let me see what it was. R, it was, oh my God. Let me go back to that because I don't have the phone. Okay, it's okay. I can go back to that. I need that information for this thing. Okay. Okay, so you said it was R, and is 1 minus R squared and minus 2. So this is the t value. So now we need to compute these things, right? So so what do you have for R? 0.81 square root of 1 minus the coefficient of determination, which is 0.66, and n minus 2. So in this case, it's n minus 2 because you have two variables, x and y. So that's going to be, here the sample size is 7. So that's going to be 5. And we need to compute that. This is the t-test value, right? So this is 1 minus 0.66 divided by 5. Take the square root of that. 0.81 divided by that number, we get 3.10. Okay, let me double check the calculation. I might do something wrong here and I don't want to make mistakes right now. 1 minus 0.66 divided by 5. The square root of that. 0.81 divided by that, we get 3.10. So that's right. So this is a two, I need to state the hypothesis, right? The hypothesis was there's a difference, there's no difference, no correlation, right? And the alternative was there's a correlation, right? Correlation exists. Okay. And what I need to do is, since this is a equal or not equal situation, I have to do a two-tail test, right? And I need to find out these values, right? So this is two-tail t-test. So the degrees of freedom is n-2. Degrees of freedom was 5, and the significance level is 0.05. This is two-tail test. I need to look for this in the t-table. So 0.05, I already found it for two tails, right? Remember, this is two tails, right? Two tails, right? So two tails at 0.05, 5 degrees of freedom. So I get 2.571, right? 2.571. So that means that this is negative 2.571. Remember, this is symmetric, right? So we get the value is 3.10. 3.10 is in the rejection region. Therefore, we reject the null, which it implies that there's no correlation. So we will say that there's a correlation. The correlation exists. Therefore, what's your conclusion? Conclusion is reject the null. And we can say that there's enough evidence to say that there's a relationship between the number of emergency calls and the temperature, right? That's it. That's how you do this problem. Next question. It is very important that a certain solution, a chemical process, have a pH of, okay, so the null is pH, pH equals to 8.3, and the alternative should be pH not equal to 8.3, right? The method used give measurements which are approximately normal, and the actual pH of the solution with non-standard deviation 0.020. Suppose a single determination shows that the pH, so let's call this pH, can call this pH equals 8.32. We decide to do a 5% critical significance level, so this is 0.05. Is there enough evidence to reject the null hypothesis? Okay, so let's check. So I need to do a C-test because they said that the distribution is normal here, right? Distribution is normal, and yeah, I have everything to do a C-test. So C equals pH hat minus pH sigma over the square root of n, right? And but this time it's just one single determination, so I don't need to put n. I just can say sigma, right? Because if I put 1, that's gonna be square root of 1 is just 1, so it doesn't matter. So pH is 8.32 minus 8.3 over standard deviation is 0.020. You divide those two, you get 1. Okay, you get 1. So this is a two-tail test, right? If it's a two-tail test and 0.05, that implies that this is 1.96. This is 1.96, and 1 is not in the rejection area, so that's in the non-rejection area. So we fail to reject. Fail to reject is our conclusion. So we should say no, there's not enough evidence to reject the null, right? So you can just read the question and you can say what's your summary, right? So there's not enough evidence to reject the chemical process have a different pH value of 8.3, right? You can say that, right? That's it. That's the end of that problem. And this problem is very easy. This is a confidence interval, right? So now data taken over a long period of time have established that the standard deviation of percentage in an iron analysis is 0.12, and that is not expected to change. A representative well mixed or sample is analyzed 6 times. Okay. If the true iron content is okay, so that's the mean, right? 32.60% iron. If there is no systematic error and if the normal distribution applies, what is the 95% confidence level, right? So this is X minus this over that, right? and this is less than, the same thing with the other, to the other side, right? Because here they're asking you for, they say that the distribution is normal, right? Normal distribution applies. Okay, so I can use the C value, right? So this is 32.60. This is 95%. You know, 95% to tail, that's just 1.96. Sigma is 0.12, 6, mu, and this thing is the same thing, but with a positive sign. And we are almost done, right? So we just need to just multiply these numbers, and that's it. 0.12 divided by 6 times 1.96, 32.60 minus the number, you get 32.5. So this is 32.5, the mean, and we got this number plus 32.60, and we get 32.7, and that's it. That's the confidence interval for these values, right? Okay, so make sure that tomorrow you bring your cheat sheet. Make sure that you understand what power means, what significant level means, what type 1 error means, type 2 error means, what is statistically significant, what is practical significance, right? Because we have statistically significant and practical significance, right? What else? Make sure that you know how to use your tables, the C table, the T table, the chi-square table. Make sure that you know your the probabilities for independence, dependence, and mutually exclusive events. What else? Make sure that you understand what the coefficient of determination means, the correlation coefficient, how to compute or find the regression line in your calculator. All those things that I went over, how to find the expectation of a continuous variable, how to find the variance, how to find the binomial distribution, or how to compute it, basically. And that's basically it. So make sure that you know your concepts too, because remember, there's going to be a multiple choice part that you need to understand, or you need to know what to do, right? Good luck on your test. If you have any questions, please let me know. Have a nice day.